P2, solving inequalities. All right, so before we get, well, we are going to do some inequalities right now, but it's important that we talk about interval notation because that is what we use a lot in calculus and what you should have used a lot of if you took pre-calculus. Actually, you did take pre-calculus. But just a quick review of that, if we see something like we have in the top right, that's going to be x is greater than or equal to 2. This one right here, -3 is less than x. That's less than or equal to 4. Keep in mind, before I get too deep into this, this means or equal to. This means just less than. Okay, this does not mean or equal to. Anytime we have an infinity sign, you're always going to get a parenthesis. If it's or equal to, you're going to get a bracket. Finally, negative infinity to infinity, we will just write it like this. Negative infinity is less than x, that's less than infinity. Cool, time to start solving a linear inequality with just one variable. So we need to isolate x. 9 minus 3x, there we go. Let's add 2x to this side and let's subtract 9 over here, giving us -5 is less than, we have to add 2 over here, so it's going to give us -x. And then finally we need to divide by -1. Anytime we divide by a negative, we flip the inequality sign. So it would be x is less than -5 is your answer. Interval notation, that would be negative infinity to -5. And there'll be a parentheses around it all. Okay, we got a double inequality here, so we need to simplify this. I'm going to sketch on a number line too while we're at it. So we need to get x by itself, so first thing I'm going to do is multiply everything by 3. -12 is less than 2x minus 3, that's less than 12. What we do one time, we must do to all the others. So add 3 everywhere, so it'd be -9 is less than 2x, it's less than 15. Divide by 2? Yeah. -9 over 2 is less than x, it's less than 15 over 2. Let's number line it up. And let's do, I always mark 0 on my number line just to kind of give a reference point. -9 over 2 and 15 over 2. Open circle, and x is between these values. There you have it. Alright, some absolute value inequalities. So, you first need to get the absolute value by itself. We're successful with that here, so we can go straight down to 1 minus 2x over 3 is less than 1, so I'm bringing it straight down. And then I'm also doing a second one where it's 1 minus 2x over 3. And then you flip the inequality sign and flip the other sign. Okay? I'm going to stick the blue on this side, and I'm going to isolate my x. Subtract 1 to both sides. That's 0. And multiply everything by 3. You get -2x is less than 0. Divide by -2, you get x is less than 0. Excuse me, it's not x less than 0. It is greater than 0 because when you divide by a negative, you flip the sign. There we go. Subtract 1, you get -2x over 3 is greater than -2. Multiply everything by 3, you get -6 is less than -2x. Divide by -2, you get x is less than 3. So interval notation, that would be 0, 3, because x is greater than 0, but it's less than 3. Alright, time to solve a polynomial inequality. I'm going to move everything on one side. Probably easier to move the 2x and the 8 to the other side. X squared minus 2x minus 8 is greater than 0. So, factors of -8 that add up to -2 is going to be -4 and 2. So what values make it 0? 4 and negative 2. So what I'm going to do is I'm going to create a number line. I like to visualize how to solve these from here. So the values make it 0 is negative 2 and 4. So we need to test the value in between them, greater than or less than, and see what happens. So pick a value greater than 4. What's going to happen? Let's do 5. We do 5, it's going to be plus times a plus. Meaning, if I put 5 in here, it's going to be a positive number, and then another positive number. So therefore, it's positive times a positive. What's it, does it get you? Positive number. Is that greater than 0? You betcha. So far, yeah, greater than 4 is a solution to this. In between negative 2 and 4, I always have to pick 0 if I can. That's going to get me a negative number times a positive number, which is going to get us a negative number. Does a negative number ever going to be greater than 0? No. How about less than negative 2? Let's try negative 3. That's going to get a negative times a negative. Negative times a negative is going to get us a positive. Is a positive number greater than 0? Yes. Once again, yes. So what's your solution? It's going to be negative infinity to negative 2 and 4 to infinity. There we go. And yes, I just realized I picked a different problem than what I wrote down on the guided notes. I'm sorry. I can do that one in class, though. Let's do that one in class. Let's save that. Alright, time to solve a rational inequality. I'm going to move one of them to the other side. I'm going to get 5 over x minus 6 minus 3 over x plus 2 is greater than 0. Common denominator, so I need to multiply the left side by x plus 2. Let's do that. And then we're going to get 5 times x plus 2 over x minus 6 times x plus 2 minus 3 times the quantity x minus 6 over x minus 6 over x plus 2. And let's FOIL and then combine. So we're going to get 5x plus 10 minus 3x plus 18. And like terms, that's going to become 2x plus 28 over x minus 6 times x plus 2 is greater than 0. Now the key intervals here are the values that make the numerator or denominator 0, meaning the zeros and the values that make it undefined. So those values are negative 14, 6, negative 2. Number line time. Make my number line green. So I'm going to put my undefined 0 values. So, greater than 6. It's going to give me a positive up top over a positive times a positive, which is going to give me a positive. So, is positive greater than 0? You betcha. So far, yay. Between negative 2 and 6. Once again, I like 0. What does 0 do? It gives me a positive up top and a negative times a positive on the bottom. No. Between negative 14 and negative 2. Let's try negative 3. It's going to get me a positive still up top. It's going to get me a negative times a negative on the bottom. It's going to give me a positive or a positive, and that's still greater than 0. So yay, still good. I'm going to big check. Then we're going to get if we do negative 15, it's going to be negative up top over negative times a negative, which is going to be a big negative. It doesn't work. So what are the values that work? Between negative 14 and negative 2 does not include them because it's on an or equal to problem. And we also got between and 6 to infinity. There we have it. So let's find the domain of this square root function. So the domain is this square root function is going to be values that make this what's inside a square root positive or 0 because it can't be negative inside here, right? So we got to factor first. It's going to be x minus 4 times x minus 5. And so the key values in this case are 4 and 5. 4, 5. Greater than 5, you're going to get a positive, we're good. Between 4 and 5, one's going to be positive, one's going to be negative, so nope. Can't do that one. And less than 4, both going to be negative. You multiply them together to become positive. So that's going to work. Yay. Now in this case, remember, what's inside a square root function can be 0. Okay, so we are going to include 4 and 5 in our solution. So it's going to be negative infinity to 4 and 5 to infinity, including 5 as well. And that's everything. Thank you for watching and listening, and you enjoy the rest of your day.